Alright, so multiplying polynomials, second day. I want to start off with this find the area of a shaded region. Alright, so we have this rectangle with a triangle inside of it. So the area of the shaded region would be the area of the shaded region. Alright, so the area of the shaded region is going to be equal to the area of the rectangle minus the area of that triangle, and that would give us the area of the shaded region. Alright, so how do we find the area of a rectangle? Alright, so the area of a rectangle is equal to length times width, and the area of this rectangle then is 2x plus 2 times 3x plus 1. Right? So using any of those three methods that we talked about in the previous video, you're going to multiply. Right, so we end up with 6x squared plus 2x plus 6x plus 2. And keeping in mind, we have some like terms here. So the area of our rectangle is 6x squared plus 8x plus 2. Now let's find the area of this triangle. And the area of a triangle is 1/2 the base times the height. Well, 1/2, the base is 4, the height x minus 2. So 1/2 of 4 is 2 times x minus 2. Distribute 2x minus 4. And now we're coming back up here and we want to find the area of this shaded region. So I'm going to take this polynomial minus that polynomial. So the area of shaded is equal to 6x squared plus 8x plus 2 minus 2x minus 4. And we've talked about when you have a minus, we change that subtraction to a plus, change all these signs. We talked about the mistakes that can happen. So x squared, there's no x squared in our binomial, so I'm just going to bring down 6x squared. Then I have x to the first, x to the first. So 8x minus 2x gives me positive 6x. And then last, my constant plus another constant. So 2 plus 4 plus 6. So there's the area of the shaded region. The area of the rectangle minus the area of the triangle. Let me get this out of the way, guys. We'll talk about that in a second. Alright, so I want to try a couple of problems here. Problems are a little bit more difficult. So example 2. Find the product. Well, we've always had a binomial times a binomial. So now what happens if I have a binomial times a trinomial? A little bit tougher, but still can do it. Now FOIL's not going to work here, because if you recall, FOIL is first. So I do have first. I do have outer. Then we talked about having the inner terms times the last term. But if you notice, FOIL neglects that middle term. Okay? So we can't use FOIL here. So you can either use the box method, or you can use double distributive property. So you're just distributing x times all three of those terms. So x times x squared, x to the third. X times negative 4x, negative 4x squared. Recall, when you're multiplying, here's where the exponents change. So x to the first times x squared gives me that x to the third. Alright, x times x gives me x squared. And then x times negative 4, negative 4x. Now, I'm going to take negative 3 and distribute it to all three of those terms. But the thing I'm going to do here that's a little different is I'm going to write them down underneath each other, keeping all the like terms together. So negative 3 times x squared, negative 3x squared. So if you notice, I'm trying to keep the x squares together. I'm trying to keep those like terms together. And then negative 3 times negative 4x gives me positive 12x. Negative 3 times negative 4 plus 12x, plus 12, excuse me. Add straight down. X to the third minus 7x squared. Keeping in mind, we do not change the exponents when we're adding or subtracting. Negative 4x plus 12x plus 8x plus 12. Alright, so you have a binomial times a trinomial. Alright, let's try another one. And you're more than welcome to hit pause and try this one on your own. This time, instead of putting the binomial first, I'm going to put the trinomial first. For whatever reason, that tends to mess up some people, but I want to show you you're doing the exact same thing. Alright? Except for this time. So again, you're more than welcome to hit pause and do this problem yourself. In this case, all I'm doing is just distributing backwards. That's all. So 5 times 4x squared gives me 20x squared. 5 times negative 7x is negative 35x. And then 5 times negative 3 gives me negative 15. Now, I'm taking this negative 2x. Negative 2x times 4x squared. And you're going to notice now we're going to end up with x to the third. Well, all I had was x squared. So I want to keep the x squares all lined up there. Alright, I want to keep those x squares lined up. So since I'm going to have negative 8x to the third, you notice I just made it its own column. I gave it its own column because it's x to the third. So I just shifted over to the left for its own column. Negative 2x times negative 7x gives me 14x squared. You notice keeping the columns lined up. And then last, negative 2x times negative 3 gives me plus 6x. Add them together, and we have negative 8x to the third plus 34x squared minus 29x minus 15. Alright? So I'm going to give you one that I do want you to try. I do want you to try this thing. So here's part C. You're going to try this one. So I definitely want you hitting pause. 4 minus 5x times 2x squared minus 3x plus 1. Again, hit pause, give it a try. I'll wait. Well, first thing I'm noticing is the negative 5x. It's not written in standard form. Doesn't matter. But I just know that when I multiply, I'm going to end up with a little adjusting. So I have 8x squared. 4 times negative 3 gives me negative 12x. And then 4 times 1 gives me plus 4. Then negative 5x times 2x squared. Here's where the adjusting comes in. I'm going to have x to the third, so I want to move to the left a little bit and give it its own column. Negative 10x to the third. You guys can do a little bit better job than I did. Negative 5x times negative 3x. So plus 15x squared. And then negative 5x times 1. And it gives me negative 5x. Combine straight down. Negative 10x to the third plus 23x squared minus 17x plus 4. Sorry, I went off a little bit off on the side, but you get the idea. Alright. Uh-oh. Sorry about this, guys. Let me get that out of the way. Alright. So here's example 3. A word problem. I want you guys doing more word problems. So you're designing a walkway to surround your rectangular in-ground pool. So you already have this pool there, and you want a walkway around it. The width of the walkway is the same on every side. So do you notice the width of the walkway is x? Alright? So the width of that walkway is x. The length of the pool, just the pool, not the walkway, is 2x plus 10. The width of the pool is 6x minus 2. And don't look at this too close because you can see I can't color. Alright. We want to write a polynomial that represents the combined area of the pool and the walkway. So now, what is the length of the whole thing? Well, the length of the pool is 25x plus 10 plus this x. And I hope you agree that there's going to be an x on this side also. So plus another x. So the length of the pool is 25x plus x plus x. So we end up with 27x plus 10. The width of the pool, or the width of the whole area, the combined area, excuse me. The width of the pool is 6x minus 2. And then again, I have that x there. So plus x. And I hope you guys all agree that I'm going to have x there, because they said the width was exactly the same all the way around. plus x. So I have 6x plus x gives me 8x minus 2. So there's the width of the combined area. All right. Now they want us to write a polynomial that represents the combined area. Well, we already talked about area of a rectangle, and it's just length times width. So I have 27x plus 10 times 8x minus 2. Hit pause. You guys try this. Alright. 27 times 8. Grab the calculator. 27 times 8. 216x squared. 27 times negative 2 is negative 54x. 10 times 8, and I hope you don't need the calculator there, plus 80x. 10 times negative 2 gives me negative 20. Well, here's my like terms again. Grab the calculator. Negative 54 plus x. So 216x squared plus 26x minus 20. So there's the area of the combined. Okay, so this is the area of the whole combined, the whole combined region, the pool and the walkway on both sides. All right, so part B. Part B, they want us to find the combined area of the pool and walkway if the walkway is 2 feet. Well, let's look back at the problem. The walkway was 2 feet. Do you agree then that's 2 feet? Here is 2 feet. It's 2 feet all the way around, right? So x equals 2. Don't make it difficult on yourself. X equals 2. Alright, so we're going to say the area of this rectangle, or this combined region, 216 times 2 squared. Let me scroll up a little bit so you can still see. All right, all I'm looking at is this right there. 216 times 2 squared plus 26 times 2 minus 20. Now you can grab your calculator and plug that whole thing in. I'm going to go step by step for you guys that don't. So 216 times, and I hope you agree that's 4, 864 plus 26 times 2, 52 minus 20. Grabbed my calculator, plugged all that in, ends up giving me 896 square feet. So the area of the area of the pool and the walkway is 896 square feet. So whatever they give us for whatever they're giving us right here, that's what you would plug in for x.